All right, we're going to operate with radical expressions today. We're going to add and subtract, and we are going to multiply. When we add and subtract radical expressions, you need to have the same common square root. Just like you need a common denominator to add and subtract fractions, and just like we do it with like terms, when we combined all parts of an expression that had an x in it, or all parts of an expression that had a y. We're going to do the same with adding and subtracting radicals. So we will jump right in with the examples. 2 square root of 11 plus 7 square root of 11. You must have the same square root in order to simplify. So what we would do is take our 2 plus 7, and we would then put our square root of 11. 2 plus 7, 9 square root of 11. So you must have the same square root in order to combine. Okay, now what if the square root is not the same? How would we simplify in order to combine common radicals? So if we have 2 square root of 20 plus 3 square root of 45 plus the square root of 180. Okay, well, we don't have any common square root right now. But if we simplified each one of these, we would probably be able to combine some terms that would be alike. So if I take 2, and I know this would be 4 times 5, plus 3, and 45 could be 9 times 5, and the square root of 180 broken down to give me a perfect square would be 36 times 5. So as we learned in the previous lesson, whenever you take a number from a square root, you will multiply it by that number in front. So this now is 2 times 2 square root of 5, because the square root of 4 is 2, plus 3, square root of 9 is 3, times the square root of 5, plus square root of 36 is 6, square root of 5. So 2 times 2 would be 4 square root of 5 plus 9 square root of 5 plus 6 square root of 5. So by simplifying each one of those, finding a perfect square as part of that value, we were able to break it down, and now they all have square root of 5. 4 plus 9 plus 6 is going to equal 19 square root of 5. So you may have simple ones where they already have the same square root, or you may have to break it down in order to simplify the expression. Okay, third example is going to be multiplication. So we have 4 square root of 5 minus 2 square root of 3 times 3 square root of 6 minus the square root of 10. And we had something very similar to this in the last section when we were rationalizing the denominator. Okay, so what we want to do is we want to do our first term. So 4 times 3 would be 12, square root of 5 times 6, which is 30. Then I would do that with my last term. So that would be minus, because we have a subtraction sign here, 4 times the imaginary 1 in front, so that would be 4. And then 5 times 10, which would be 50. All right, now we're going to do the same thing with the second term. So negative 2 times 3 would be negative 6, square root of 3 times 6, which is 18. And then the second term over, and that would be plus, because a negative times a negative is a positive, 2 square root of 3 times 10, which is 30. All right, now we need to break these down if we can. So this will be 12 square root of 30. Can 30 be broken down into a perfect square? No. So that's going to stay the same. Minus 4 times 50 is 25 times 2. Minus 6 square root 18 can be broken down to 9 times 2. Plus, we already said that 30 cannot be broken down. All right, so 12 square root of 30 minus square root of 25 is 5. 5 times 4 is 20. Square root of 2 minus 6, the square root of 9 is 3. 6 times 3 would be 18 square root of 2 plus 2 square root of 30. Now we can combine terms that are alike. So we know that 12 square root of 30 plus 2 square root of 30. So that would be 14 square root of 30. Negative 20 square root of 2 minus 18 square root of 2 would be minus 38 square root of 2. So that would be in simplest form. All right, one more quick one, because you have one of these and I don't want you to think that you're going to be distributing that square root symbol. This is example 4. If we had the square root of 3 plus 4 raised to the second power, you're not taking that second power and distributing it. The whole expression is raised to the second power. Therefore, you would rewrite this as the square root of 3 plus 4 times the square root of 3 plus 4. So the square root of 3 times the square root of 3 would give you the square root of 9. The square root of 3 times 4 would be plus 4 square root of 3. We would do it again from the inside. That would also be 4 square root of 3 plus 4 times 4, which is 16. We know that the square root of 9 is 3, plus 4 plus 4 is 8 square root of 3, plus 16. 3 plus 16 is 19, so 19 plus 8 square root of 3. Just remember that this whole expression has to be multiplied by itself. You are not distributing that exponent.